Hi, welcome to Precalculus. Today's topic is converting an equation written in polar form to one written in rectangular form. Let's just remind ourselves again the relationship between the two types of coordinate system. You can write x equal to r cosine theta, y is equal to r sine theta, because if you have a point with coordinate x, y, x plays the role of the adjacent and y is the opposite. The angle is theta and hypotenuse is r. And the relationship works even if r is taken to mean a negative number. On the other direction, we have r squared is equal to x squared plus y squared. And then tangent of theta is equal to y over x. Okay, so r squared is just a Pythagorean theorem telling you hypotenuse, sum of square of these two. In case r was negative, when you square it, it becomes positive. Tangent of theta is just a ratio of opposite to the adjacent, and for all cases, this one works as well. So these things give us very simple recipes. For example, if theta is 5 pi over 4, let's graph this thing to see what does it mean. 5 pi over 4, what's that? Pi plus pi over 4, this is 5 pi over 4. Now if I take positive r's, I'll be covering all these points. If I take negative r, then I'll be covering these points. Well, now what we have, the question is, what's the equation of this? What's the equation of this line in the Cartesian system, in the rectangular system? Well, this is the line y equal to x. That's all we needed to know. So we go ahead and we say we have tangent of theta is y equal to x. So tangent of theta is just 5 pi over 4. 5 pi over 4 over is equal to y over x. Tangent of 5 pi over 4 from this reasoning is 1. 1 is equal to y over x. So if you simplify that, you get y is equal to x in rectangular form. That is, so the equation that we are after is simply y equal to x. How about r cosine theta? R cosine theta is equal to minus 7. So who was r cosine? R cosine is just x. R cosine is x. And our translation is very simple. This is just x. X is equal to minus 7. Which is what? Which is an equation of a line that goes vertically at point minus 7. And that is what is being represented by this equation. So our final answer is x equal to so x just equal to minus 7. So most of these are very straightforward. This one, r cosine theta, that's just again x. So the translated form of this equation, rectangular form, is x equal to 8. R is equal to minus 4. That's a little bit odd looking. How can r be negative? We said, you remember, if you have a certain angle, that angle here is going to mean that you take the x-axis and just turn it into that position, so angle theta. So that's an axis. If you consider points on this side is positive, points on this side will be negative. So when we say r equal to minus 4, simply means pick any angle you want, and then to choose your point, go in the opposite direction by 4 units. Well, if r is equal to minus 4, how can we convert it to anything? We are going to use this. We square it. So I'll have r squared is equal to minus 4 squared, which is, well, 16. R squared, we said, is same as x squared plus y squared. It's a Pythagorean theorem. Our equation becomes x squared plus y is equal to 16, which is, of course, equation of a circle whose radius is 4. So that is our final form here. Here's another example. First one, we learned to say y equal to x is equal to tangent of theta. So y equal to x is equal to tangent of 5 pi 6. This is just 30 degrees short of becoming horizontal, and its tangent of that is going to be minus radical 3 over 3, or look it up on your chart. So y is equal to minus radical 3 over 3 times x. So that is going to play the role of the slope of the line. That is the slope. So that is the equation for this one, and this is easy. R sine theta, we learned that is just y. Y is equal to 8 is the solution of that equation. So again, we are learning how to go back and forth between these coordinate systems, and major uses show up in Cal 2 and then later on in a variety of classes. Okay, until next time, good luck and God bless.